Hello, everyone, and welcome to our second webinar hosted by Youth Science Canada called Stepping Up. My name is Kelty Murdoch. I'm a CWSF alumni, and I'm currently studying computer engineering at UBC. I'm joined here by a couple other alumni. Please feel free to introduce yourselves.
Hi, I'm Farouk Salwani. I'm from New Brunswick, Canada, and I'm third year in biochemistry at University of Moncton. I've been a participant in the CWSF 4 times.
Hi everyone, my name is Jasmine. I am currently a third-year student at Dalhousie University in Halifax, Nova Scotia. I was a finalist at the Canada-wide Science Fair 3 times and a delegate as well last year.
Hi everybody, I'm Jessie McAlpine, and I'm currently a third-year student at the University of Toronto studying microbiology and computer science. I've also been a participant at the Canada-wide Science Fair 5 times, and then I've returned in different capacities since then.
And I'm Kate Berger. I'm currently studying chemical biology at UBC, and I did 4 Canada-wide science fairs, and 3 of which were with Jasmine Brar.
Awesome. So I just wanted to let everybody know that if you ever have any questions during our presentation, please feel free to ask them either within the Hangout, there's a Q&A section, or you can ask them through Twitter using the CWSF hashtag. So it's just hashtag CWSF. All right, so for those of you who tuned into our last webinar, we were talking about a little bit about how to get started with your science fair project. So this one is more focused towards maybe taking your project to the next level, maybe going on to the next step or the next level competition, or really just taking your research deeper and further. And we're going to talk about what that means and maybe a little bit more of how to do that.
Yeah, so there's several ways you can step up your work. One has to do with data interpretation. So if you go more in depth with your data analysis and you're more specific about the interpretations you're making. Another way is to expand the impact of your project and look into the real-world applications and how you can make your results really meaningful to other people. And then, of course, you can also step up your presentation skills as well. So things like showing excitement and tuning up your skills to present to the judges.
All right, so to you guys, what does it mean to really step up your work? Like on a personal level, what does that mean to each of you?
For us, stepping up our work means that going a little bit more in depth and being more specific in your interpretation of the data, right? So you want to look at how far you can go with the graph. So maybe add a little bit more in your data samples, maybe add a little bit more in your statistics. So new theories, new distributions. You can do many things to taking your work to the next level.
Yeah, so specifically with data interpretation, one of the things you can do is look into statistically analyzing your results. So for one of my projects, I was counting concentrations of parasites at different locations, and so I would have a lot of data points. I think maybe up to 25 per each location. So I would average them, so I would know what the average concentration of parasite was at each location. And instead of just comparing the averages, you can look into the range your data has at each location through something called standard deviation. And then you can put error bars on your graphs, so you can compare the range that your data is in, and this will make the conclusions you're drawing from it more scientifically sound.
And so, sorry?
Oh, I was just going to say, speaking on that level, a lot of the, like, if you don't know exactly how to do all those different tests, usually just through, like, Google, there's lots of great online resources that you can look at to help you learn very basic statistics.
For sure. And what do you think is the value really in making your data more analyzed statistically? Like, what is the value from a science fair perspective in amping up this math or this interpretation?
Well, I think what it helps with is it helps that when you go to explain why your results matter, having the statistics and the math there really indicate that it's not just you interpreting the results, but there's actually like math behind the conclusions you're making, and that helps make them stronger. So to the judges, they can see that your work is verifiable, kind of, and that it's supported by all of these numbers.
Overall, it just really strengthens your conclusion, and judges do find it to be quite impressive, especially if it's like a statistic or something that's just not something that you might be learning in school. You know, you've gone out and you've like learned something outside of a classroom setting. Yeah.
Right. I think that. Sorry. Go ahead.
Yeah, it really shows investment in your project. So yeah.
Yeah, I think it's super valuable when you show that extra interest and you take that extra step. And that totally reflects in your presentation as well, and it comes off in your enthusiasm, and that's one of the most valuable parts of doing a science fair project. So, that said, why should somebody take their work to the next level? Like, why is it important?
You know, it helps to better like present the impact of your work. You can help to inspire other people as well, and this could also be like the difference between like a side project that you're having or like a project that's going to impact like society as a whole, I guess. If anyone wants to add something to that.
Yeah, so going back to the example I had with the parasite project, we took our work to the next level because we saw that our data could have an impact on public health. So basically what we were doing is we were taking concentration levels at each different location, and based on the environmental distribution of these parasites, we could draw conclusions about how they were entering the environment and things like water pollution. So we chose to continue to research this further because we saw a direct impact of our results.
For sure. I know I did a lot of work that was very similar, but like same but different kind of thing. And I like to take my work further because I always had these unanswered questions, and I really wanted to dive deeper into, you know, maybe I had some anomalous data in my first round, and I wanted to know what that meant and how I could control it or how I could use it to my advantage. And that sort of knowledge is always very, very valuable in the scientific community, not just in science fairs, but everywhere when you go on to, you know, further on to post-secondary or maybe a job. It's always important to keep asking those questions.
Yeah, it's the same thing for me, right? So when I make my projects, usually I really try to work on the ending, so I really try to finalize it, but sometimes I really can't, so I just keep trying to make it better, and eventually that takes me to another level completely, and sometimes it just happens, right? I know it sounds sort of weird, but sometimes it really just happens when you have such an investment into your work and you really want it to make it better.
So is it more like what you're saying that the impact and your personal interest in the project is definitely a drive for this?
Yeah, definitely. My personal interest is I'm not saying it's the only thing that I really care about, but if it's not there, then it's basically not something worth doing because I know that my work is subpar when I'm not interested to something.
So when you're so interested, like, do you have any examples of how it was made better? Like maybe something that happened in your work that you noticed you were taking it further? Like any?
Right. So basically, once one of my projects was programmed to help for cancer diagnosis, right? So at the end, when I was working with it, I realized that my error rate was really good. So what I did was I didn't want to just focus on breast cancer. I wanted to focus on other types of cancer. so I found different databases. I found different people to speak to about different types of cancer, which I wasn't really acquainted to at the time. I didn't know about prostate cancer. I didn't know about other types. So what I did was I did my research on that, and I really made that mine, and in a way that I made it into my project. So that's the way I ended up making it back.
Right, so it was made better by sort of developing the scope of the project.
Yeah, yeah.
Awesome. Do you know of any other ways, does anybody know of any other ways you could make, or you could find ideas on how to step up your work?
I would say just make sure that you're really like reading up on what your project is about. So, your project is something that you should be relatively like an expert on. So, there are many resources out there, and I think a lot of the inspiration that Kate and I got for our projects was that, we would read a paper, see like, oh, they did this thing, we would maybe like investigate that. For example, we found a paper about how people were using fertilizer from wastewater treatment plants. Like sludge or sewage from wastewater treatment plants as fertilizer, and how it could even end up on plants. So we had a whole new phase of our project that just dealt with plants. And so it can be anything really.
And I think another great thing to do is if there's someone you've been working with or someone you know who might do work in a similar area to yours, it's always great to chat with them about the specifics of your project and see if they have any suggestions for you to step it up, and whether that's a parent or a teacher, or if you actually want to find like an individual at a university, for example, who might work in your field. I think that's a really great way as well, because sometimes it's daunting to just sort of like search all of the internet to try and help you direct your project, and I think it can be really helpful if you can talk to some people who know about the area you're studying as well.
So I believe you could all see the slide right now. There are some other resources you can access online or whatever, just to kind of maybe brainstorm a little bit in ways that you could stretch your idea. For example, the slide shows you can Google, or there's a Stepping Up guide produced by Youth Science Canada, which is a really good way to focus on how to fine-tune your presentation and how to really just get a better feeling for science fairs. Of course, Youth Science Canada offers programs, or maybe regional fairs offer programs on mentorship, and there's always friends and family to ask as well. So we have a question coming in. It says, do I need a mentor, and will everybody at the Canada-wide Science Fair have a mentor?
Sorry,
Go for it. That's okay.
All right. So basically, not everybody at the science fair will have a mentor. I didn't. I know many people didn't have one, and you definitely don't have to feel bad. It's a good thing to have one. It can't really be that detrimental, but it's definitely the way that you use it, right? So if you want a mentor, maybe it's somebody who can help you get into a lab, or somebody who can help get you the resources you need. My projects didn't need those kinds of resources, so I didn't always have the need for a mentor. So that's for me.
What about other... Oh, sorry, go ahead.
Yeah, I think it absolutely depends on the kind of research you're trying to do, and also your future goals as well. For example, having a mentor in research helped me to get into other opportunities with research. So if that's the direction you're thinking of taking, having a mentor in a lab might be very advantageous to you in the future. But for science fair, there are all kinds of good ideas, and you don't necessarily have to do your project in a research lab.
Mm-hmm. Like Kate and I, we have both done a project together. Like we've done 3 projects together, and our first one we actually didn't have a mentor, and like we still did fine. We had all the resources and everything that we needed. We attended Canada-wide Science Fair, and the next year when we came up with a new project to do, we just knew that we did need a lab setting because, and as well as like a mentor would be useful because some of the things were fairly complex, and it was great having the opportunity to work in a lab because our mentor led us to like resources and things that we may not have like known about, and we got to work with equipment that we needed for our project. But again, yeah, it all just depends on your project, and having a mentor is it's not going to be the end of the world if you don't have one. I mean, we didn't have one, so.
I also think it's important to know that like a mentor doesn't have to necessarily be someone at a university either. A lot of students I know have had mentors who are their teachers at school, or a parent, or even like an upper year student that they know from science or from school, because sometimes you can get a lot of the resources you need from your school alone. So don't worry if you can't necessarily get into like a university or research laboratory. There's other ways to get help from people in your lives without it having to be a professor, for example.
All right, so I think the takeaway from that is that if you have a mentor, that's great, but you absolutely don't need one. And it's not going to hurt your work as long as you are doing, you know, original, creative, scientifically sound work. Then I don't think not having a mentor will really hurt you. Anyway, thank you so much for that question. We have another question coming in that says, how do I get access to materials that may be really expensive? So maybe you do want to have a mentor, you do want to access labs or tools, or even, I know I used heavy-duty machinery. How do you get access to those sort of things?
Well, for the first project Jasmine and I did together, where we actually didn't have a mentor, we were testing different kinds of landfill liners, and we wanted to test some of the ones that are actually used. So we contacted a company in Calgary, and we asked for samples of the different kinds of liners that they manufactured for landfills. So if you just ask manufacturers for their resources, they may be very willing to help you, especially if they have their own company. And I think it also helps to have a really good plan of what you want. Like if you think it's going to be expensive, how much do you want? What are you going to do with it? And yeah, go from there.
I know back in my science fair days, there was one project where I wanted to dig this really large trench because I was working with geothermal heat. And obviously, I mean, I didn't have really the money to just hire a backhoe. So what I did was I looked online for youth research grants, and I applied for one, and it was just small. It gave me the money I needed to just kind of get my work done, and when I was finished, I had to write a report on what I used the money for and what I accomplished and what I found. But I just want to say that those sorts of things are available, and a quick Google search can bring you to application pages for a lot of that stuff.
Yeah, definitely. Sometimes I needed, for my 10th grade project, I needed spectroscopy, NMR. So I don't really have the resources. At the time, I was in 10th grade, so I didn't know that there was that at the university. So what I did was I gathered data instead that wasn't mine. I found it online, so in a database. So you can always look for other ways to find data that maybe you can't find somewhere else, find on your own, I mean. So, yeah.
Awesome. Well, thank you so much to the person who asked that question. Our next kind of idea is what are some of the directions you can go when it comes to stepping up your project? You guys have any ideas on maybe different types of ways you can make your project better?
Well, definitely you can work on your presentation. So that's one big thing that's very important. Working on your presentation is one of the most important things. I mean, you have to not make it look scripted. You have to really make it in a way so that when you're talking to the judge or to the person, that it really fits the conversation you're having. So if that person is a doctorate from Yale, then yeah, you can go full on, statistics. Here's my data, whatever. But if it's a kindergartner, then you don't want to go really into detail. So you really need to make your presentation a lot more flexible. So yeah.
And what are some of the ways you can kind of do that?
Making your presentation more flexible is really, since you made your own project, you really know what's really the innards of it, the inner workings of it. So you really can. Einstein said, I think, that the best teacher is the one who understands the. Never mind. It was totally wrong. So yeah, as long as you really know your project, you can really dumb it down, right? So just keep practicing to other people and try to make it better.
Yeah, and I think one really important thing to say would be like your science doesn't quite matter if like you can't convey it.
So, do you think like it's probably important to have like different language for different people, right?
Yeah, absolutely. Like, so if you get a judge, which is maybe like a professor or a teacher or something, or even like an expert in like your field, for example, you'll definitely want to go into more detail of like the science behind it, your background research, and really, I guess it would be more complex in a way. But if you're talking to like a high school student or something who's just there to like get interested in science fair, it probably won't be like as complex. You're going to simplify it, but it's not dumbing it down exactly, but it's like, you're an expert in your project and you should be able to explain it at all different levels.
For sure. I think it's good to make, I know personally I always had like a 30-second summary. I had a 2-minute presentation, I had a 7-minute presentation, and then I, of course, had the presentation where I just like talked forever and bored everybody to tears, but that's not really necessarily the best one. But I know like it doesn't make it any better. Like you're not going to impress anybody by using a bunch of words that no one understands. Be able to, like Jasmine said, convey your information, and that can make your presentation just so much better.
Mm-hmm.
Sometimes what I used to do is before I would talk to a judge or someone from the public, I would ask them kind of like what they do, like what their background is. For example, some of my projects were a little bit more medically related, so if I was talking to someone in the medical community, sometimes I would try to tailor my talk a little bit more towards that because they might understand more of the technical details, whereas if I was talking to someone from the general public who might have been I don't know, a mechanical engineer, for example. They might not have known a lot of the specific medical terms and ideas and things, so instead I would try to focus on the broader concepts, and I found that helped me communicate my project better, but still allow me to showcase my knowledge and some of the technical details I did know when I knew that the person I was talking to would be receptive to that.
Yeah, definitely what's a good idea to do when you're talking to the public is, if you have the time, just start with small talk, not necessarily about your project, but get to know the person you're talking to. So yeah, since it's on the judge's side, you already know because it's on the sheet, right? So he's a doctor or he's from the oil companies or something. So, but if it's the public, try and make small talk and get to know the person.
Mm-hmm.
Yeah, I know something that Jesse said about maybe having like a mechanical engineer come check out your biomedical project. It's kind of also a good idea to know that not every judge or not every person, even though they could be a technical person and have a great amount of expertise in one field, it might not be your field, and that's super important to notice. So it is always good to know, like especially if you have some parts that do require a little bit of technical background, you can always ask, like, are you familiar with this, or have you heard about this, or do you know what this means? And nobody's going to be offended by that, and it's a great way to get everybody on the same page. So that's always super helpful in presentation.
Like one of the things that Kate and I used to do before presenting was, it's like, oh, have you heard about these parasites before? Which is what our project focused on. And because they were quite unknown, like, you know, sometimes they wouldn't, so we would like go into a little bit of the background of it. But it was really cool if they already did know a little bit about it, so that we didn't have to go into like the life cycle of these.
And then
like,
you can tie it into your project if they do know. So they'd be like, oh yeah, my dog gets this disease like every year.
Yeah.
And you're like, oh, okay, so this is what it looks like.
That's kind of sad.
Lots of dogs get Giardia. It's totally normal.
Oh, okay.
Yeah.
Perfect. One thing I definitely wanted to mention that we kind of touched on a little bit before, that in terms of presentation, the talking isn't the only way you can step up your presentation. Data interpretation and presentation of your data is also huge. I know we mentioned talking about some statistics, like maybe just figuring out your margin of error on your on all the data points you collected, or increasing your sample size, or maybe just going deeper with the data is super important. But also, I wanted to ask a question about what should go on your board in terms of data and in terms of words and findings and everything, just to make it a good presentation.
I think you always want the information on your board to reflect the most important parts of your project. So a lot of the times, because science experiments can be pretty complicated, sometimes you can end up with lots and lots of graphs, like 20 graphs or something. But sometimes putting that many graphs on your board isn't as effective, because a lot of the times you sort of want to have the key points of your project. So what I used to do is I would choose the graphs that I thought best reflected what I wanted sort of the goal at the end of the day of my project to be, and then the rest of the data in the graphs I would keep next to my project in like a binder, so that the data was still there, but then when people were looking at my project, they wouldn't get kind of lost in the numbers. Instead, they could easily connect, like here is one of the main points of the project, and right there, that's the graph or the chart or the data that supports that claim.
So maybe in your own experience, what do you think is better, like more pictures and more graphs on your board, or more words?
Definitely more pictures and graphs and things. It's always important to have a few words, because otherwise people won't know what they should exactly be interpreting. But the more pictures and graphs, the more visual it is, the more it will grab people's attention, and it also helps you, because when you're giving your presentation, it's much easier to look at a visual cue and have it remind you of what you want to be talking about, as opposed to, as you're presenting, trying to also read the elements on your board, and sometimes that could make you get lost or stumble through your presentation. But I found that seeing a picture of like a cell or something would remind me that, oh yeah, I wanted to talk about this one element of how a cell is made up.
Exactly. Like, just put on, like, your poster board should also still have that information, that if, you know, you're not there, that people would still be able to look at it and understand what your project is about. But it also should not be the exact same thing that you have in your report. Like, you already have your report there. If someone wants to look at it, they can. I'm talking about, like, if someone from the public is. And but your poster board is really more of an aid for you when you're presenting your work, as Jesse mentioned.
Right, and I'd like to add, though, no matter which way you decide to go on your board, the important thing is the way that you're the most comfortable with. So no matter, you don't have to feel obligated to only put pictures on it. I know a lot of people, you know, from Quebec and especially, they only like to put images and fonts on their boards. But personally, I like to put some amount of text on my boards as well, because that's the way I was most comfortable. However, that did not mean I was always, you know, turning back and reading on my board. That was just, that never happened, because the way I was most comfortable was just having the words there in case of, I don't know why. But it's just the way you have to feel about it, and you know, yeah. I also believe that your board should convey your project when you're not there. So yeah.
Yeah, going back to what Farouk said, I think for the text, it's fine to have a summary text for each section, but you definitely want to cut it down. So I know, like, when I first started with science fair, there's a tendency to basically take your report and like put like these same paragraphs under like purpose and background, but you don't want to do that. You want to summarize it and have the most important points on the board.
That's true. Actually, that makes me think of, Kate, what you were saying earlier about you were speaking about coming to potential mentors or people with your goals in mind. And I think you can relate that to your board in your presentation, because it's really important to know, like, when people come to you and they want to know what your work is about in 1 minute, it's good to know, it's good to say what your goal was and then what happened in the end. And then if they want to know more about your method or whatever, it's really good to be able to go into that as well. But it's so important to have your hypothesis or your abstract or something on your board that just says, this is what I was trying to do. And then conclusion, this is what I found. And I think that's just like the most fundamental part of your board and your presentation and your project, really, because that's what people want to know. So, what about maybe stepping up your work in terms of background research? Do you have any tips on maybe how to make the groundwork that not many people see like a little bit more significant and more important?
Oh, sorry. Go ahead.
Oh, I was just going to say, I know we talked about it before, but finding scientific papers that relate to your work and really correlating with that.
Yeah, and what I think you should always do is not only always keep reading up on your subject, so always keep reading up on medical reviews if you're still doing a medical project, but also go a lot more in depth with the theories, like the statistical theories, the probability theories, any sort of theories you're having on your project, and understand them much better than you did beforehand. So if you're using the different distributions, really understand what each of the the variables mean, and how they can affect your project. So yeah.
I know something that's actually really important and really helpful, and always was helpful for me, is also just knowing similar studies. So you can do kind of case studies. You can read past projects that have found things that might be important, might save you a lot of time in your work. I know for me, I was doing, like I said, my work with geothermal, and I didn't have the time or the money or the expertise to, build heating system right from scratch, and I didn't have the expertise to put together my own heat pump, which is something that works in a home, which is already like manufactured. So I know just reading about existing types of geothermal systems gave me such a strong knowledge of what was out there already, and how, like, it also gave me a knowledge of how my work could be different and ways that I could change it. And so that's super important when you're doing your background research. So we have a question coming in. Where do I physically find medical or academic journals, or how do you access them?
That's a great question, and one that I know I struggled with for a little while. But one of the best resources is, again, talking about Google. If you go to Google Scholar and search any term, so for example, geothermal, then it will come up with relevant papers and things, but they're all from academically inclined sources. So it's only going to come up with journals and all the articles that you're probably interested in, as opposed to maybe like news articles and things. So Google Scholar is a great option, and then for most of them they have like a separate link so you can access the full article, because sometimes you aren't able to if there's like copyright issues. So just check that before you read an article that the full article is available.
That's true. And what happens if you find a really good, well, what seems to be a really good article, but you don't quite understand all of it? Does anybody run into that before?
Oh, actually,
Yeah.
I still run into it sometimes when I do research for university. So I believe that's one of the key things to really work on your project is when you're reading up in the very, very beginning, before you even, try to step it up, you really need to begin to understand the language of the project you're making. So if you're working into, I don't know, medical field, you want to understand your PubMed articles, which is another great source, by the way. You really want to always keep reading up before and understand. You might even just want to Google the terms if you don't understand them, but any way you can understand them, maybe ask other people, maybe ask other people in the field or people who might know. So really keep working on it.
Yeah, and then there are several other things you can do as well to find references. So if you get a good research paper and you read through it and you think it's really relevant to your project, you can look at all the references at the end of that paper that they referenced, and then you can find a lot more papers that you can in turn read to develop your project. And then the other thing I wanted to mention is if you live in a place with a college, you can go and you can get a library card to the college, and then you can have access to their online paper databases. So you might be able to find things that otherwise wouldn't be easily accessible on the internet.
Mm-hmm. One of the things that I really found useful was, going to a college, but actually getting some textbooks. And so like my project that I did, it had to do with some of the things that I was learning in school, but it was a little more complex. So I just picked up a university textbook, saw the chapters I needed to read, and started studying those. So, your background information is quite important, and that can also lead to finding more resources as well, yeah.
And you could always ask for help too. I mean, if you know somebody, maybe they don't have to be an expert in the field, but maybe you just know somebody who works in science, who's like a teacher or parent or someone, you might be able to ask them, oh, I don't really understand what air-to-air heat exchange is. Do you know anything about that? And then they might know through some of that meteor reading. So one thing I really wanted to mention while we're on the topic of background reading is the importance of a bibliography, and we should talk about maybe where that goes on, like in your logbook or just in your report or anything like that. Do you guys have any experience with like keeping up a bibliography and its importance there?
Yeah, like there's no way to properly stress how important bibliography is because as scientists and people, anyone in academics really, it's very important that you show which ideas are yours and which ideas came from someone else. And the easiest way to do that is through referencing. So it's very important that not only is there a bibliography in your report, but also displayed on your board. And usually the best place to put it is just maybe at the end in like the bottom right-hand corner is where I would usually put it on my board. And it can be smaller than the rest of your text, but it's very important that it's there. And there's many different kinds of referencing styles. And I don't think Use Science Canada requires a specific one, so it's up to you, whichever referencing style you would like to choose. I usually use APA, and all of the kind of rules behind using APA are available online. If you Googled referencing styles, there's all kinds of resources online that show you how to cite and how to make sure it's all proper so that if people want to know where you got your information from, you can direct them to your bibliography and they'll be able to find out.
Mm-hmm. Yeah, referencing is very important because, if you don't reference something, you just really want to be careful of like plagiarism. and that can sometimes get like very serious. But yeah, it's just keeping the difference between like what's your work, what are your thoughts, and what are someone else's thoughts. Yeah.
All right, well, just to summarize that question, I remember they asked, where do you find good academic articles, and what do you do if you don't understand them? So I just wanted to say online, talk to people, go see your college, and if you don't understand them, always talking to people or doing more background information, or again, Google is a great way to do that. So thank you to who asked that question. And we got another question just coming from that discussion. How do I properly take notes and or keep a logbook?
Well, I think those two things are separate things, at least for me in my projects anyways. So when I was reading all these papers, we had a binder of papers, and then we would have a separate notebook that went with that for our background research and relevant points. And if we found something we thought was interesting or important, we would write it down, and then we would write down which paper went with, so when we were writing our background, we could easily reference it. But we wouldn't put these things in our logbook, though. That was just for the actual research that we did. And so each day we worked on our project, we would start with the date at the top, and then we would write out like the objective of what we were trying to accomplish that day or continue from the previous day. And then this is where you'll write down all your raw numbers. So we would write down exactly how we were doing things and all the data points we were collecting. So like for our project where we were counting parasites, we would count them under the microscope. So we would have the sample name and tally marks for each parasite we saw in the slide. And then later when you're analyzing your data, you'll take the raw data from your logbook and summarize it. So we could average the number of parasites at each location from that information.
Right, I know my logbook was actually like, it was like a collection of all, like everything I had laid my hands on, all in a book, and I just had it separated out by tabs. Like I had a data tab where it was just all my raw data, and then I had like a notes tab where it was observations and like questions, and then I had a research tab, and like everything that I had touched over the course of my project was in my logbook. And so if anybody asked me any kind of somewhat obscure question, or maybe not even that obscure, I could speak about it, and then if they wanted to know more, I could actually direct them to my logbook and say, look, this is what I did, and this is where I kept it. And I found it made it really organized for me too, just to kind of be able to flip through my thoughts in a sense in that way.
Yeah.
Oh, go ahead.
What I had was two different binders. One for my the articles that I use. I actually kept the entire articles, and well, not the entire ones, but the parts I used, and kept them in a different binder. While I also had my own logbook, which I noted everything I needed to write down. So basically, yeah, I always kept them separate.
Perfect. So thank you so much for that question. I have my next question ready. Is what does it mean to be more statistically accurate, and what does it mean to recognize error or find error in your data when you're interpreting it?
Well, I think it's also important to know that, like, first of all, if you did find an error, that's okay, because it's important to show that you recognize where there might be faults in your experiments, and judges will not penalize you for that, because it's really important that scientists critically reflect on the work that they do, because that's how you improve, and that's how you recognize where your next steps are. But statistically speaking, if you do find an error in your data, one thing you could do is then use that as a next direction. So, for example, if you found out that you had made a conclusion and it wasn't statistically supported, that would mean that you had made a false conclusion. But maybe if you increased your sample size, for example, that might not be the case. So if you had only tested 3 grass plants or 3 dandelion plants, and to get a statistically significant result you needed 10, then maybe you could go back and look at trying to use a larger sample size and then see how the results turn out.
And so what happens if a student maybe doesn't know where to start with statistics? Like maybe they didn't get it in school. What's their first step in actually choosing a sample size and analyzing it from maybe a more mathematical perspective?
I think the best way to do that is to look at other projects which are on the same level. So in a previous webinar, we spoke about there's a database of all the projects from the CWSFs from years past. So that's one actual good way to look at the number of the data samples that people use. Also, I believe that just going online and looking at other, research about that thing really helps. But yeah.
Just a question coming in. Somebody wants to know why are statistics important and what do they do in terms of presenting your data?
Well, I think to go back to what I was talking about earlier, statistics will give more validity to your results. So if you have averaged some data points for like each location of parasites and you want to compare them, you might say that it looks like the average for one is higher than the other. But if you look into the range for all your data points, you may find that the ranges are actually overlapping, and you can't actually prove that one location is higher than the other. Or you might find that the ranges are not overlapping, in which case it makes a very strong argument for that you have discovered that it is actually different at the two locations. So there are lots of different ways that you can calculate ranges of error. A very common one is called standard deviation, and you can easily find instructions for that on the internet, like Jesse said earlier.
Definitely.
Yeah.
I used standard deviation when I was doing my geothermal work because I would go out every day. At first, I would go out every day and I would take temperature readings at different points, and as the months progressed, these temperatures fluctuated because it was a natural environment. So standard deviation actually came in handy for me because it made me sort of quantify the actual gain, the heating gain that I was getting from my work, rather than just show that the weather is changing.
Yeah, if you want to get more into the mathematics of it, anything that has to do with variance, so that includes standard deviation, is really important to know. So basically different types of distributions. The normal distribution is one that's really important to know. You can Google a lot of things about that, and it's very well documented. But the normal distribution helps you understand your data distribution much better. So you know what ranges you're in, what data is really most important, I would say. So especially if you're working with living organisms like microbes, that really helps. So understanding that kind of statistics is important.
Mathematically, if you look at the formulas you use when you calculate standard deviation, it takes into consideration the number of replicates you have for each sample. So if you were to take a lot more data points, it will make your error bars smaller. So that's one of the reasons why it's so good for your project to have lots of replicates, is because it makes your results more scientifically valid. So for our parasite project, we had a lot of replicates, especially for some of the samples we were taking on a weekly basis for a long time. So I think throughout the course of the project, for some of the locations, we had almost like 100 replicates by the time we got to nationals. And the judges were really impressed by that. And I mean, I don't think you need to necessarily have 100 replicates. If for like regionals, I think like even 10 would be good, but the more replicates you have, the more likely it is to show that your results are valid.
I know usually when we run these webinars, we have one alumni who mentions that in her past work, she started off with 100 sample data points, and then after that, when she decided to step up her work, she went to 1,000, and she found that that was an appropriate way to step up her work going to nationals.
Mm-hmm.
So we just had a question coming in from our Twitter feed that was, how long should your presentation be?
Oh, go ahead.
Oh, okay. Well, it definitely depends on the audience you're presenting to, right? So in the morning for when they analyze your project for metals, the presentations are, I think they give you a 20-minute window, right?
Mm-hmm.
And I think you wouldn't want to fill this entire thing speaking because they'll want to ask you questions as well. So you might, whatever the time window is, you want to aim for a bit below that. And then depending on your audience, you're also going to want to have a shorter summary prepared because sometimes the judge might come by in the afternoon and be like, I need like a summary of your project and I have 5 minutes. So I think it's really important to be flexible in how long your presentation will be.
Mm-hmm. And in the evenings, like so in the mornings you have your like general award like presentations, and in the evenings it's more of the special awards. So sometimes you may want to kind of tweak your presentation a little bit. So for example, Kate and I, we had a presentation that we had to do to a judge that was mainly focusing on just water. So we didn't talk about like the health aspect of our project too much, and we mainly just focused on the impacts of parasites in like water quality.
Yeah, and definitely one of the things that I always did, even though it was really never required for a presentation, was a 30-second, overview of my project. So I really didn't get into any of the procedures, but I got into my goals, my results, and mostly it's to get a feel of the person you're talking to, if they're interested in your presentation or not. Because when it's the public's time, there's over 400 projects at the National Fair, so they might want to look at most of them, and they don't want to always have a 10-15 minute presentation given to them. So you start with a 30-second elevator pitch, and you try to work with that once if people are interested or not. So
I know when I was doing my presentations, I would kind of intro it. Oh yeah, I developed a heating system because I was really tired of being cold all the time. And then they'd kind of laugh. Not that that's really a great joke, but they'd kind of laugh. And then I'd be like, well, actually, here's what I did. And that was always like a good way of just kind of setting the tone and just, I don't know, taking the edge off. Sometimes like you're a little nervous, I don't know, but it takes the edge off when you could just say something unrelated to your project first, or like semi-related.
Mm-hmm.
That being said, do you guys think it's important how you dress or how you physically present yourself, like, or is it more about the science, or what do you feel like that?
I think it's kind of a little bit of both, because obviously you want to dress in a way that I think is presentable, because it indicates that you're like ready and excited, but the other thing is that you want to make sure that you're comfortable. So if you're not comfortable wearing a suit to be judged in, then you don't have to worry that you don't want to wear a suit. You can wear something that makes you feel comfortable, but also you probably shouldn't wear sweatpants because sometimes that can show not necessarily disrespect, but just the judges and you are there in a professional capacity, so it's nice that you and your attitude reflects that. So you want to present yourself in a professional manner, and one of the ways that you present yourself is through the clothes that you wear. But also make sure that you're comfortable yourself, because you don't want to be nervous or worried on the day of judging just because of what you're wearing, because at the end of the day, it really is about your science and what you did.
Yeah, you definitely you have to dress for the day you're having. So if you believe you're going to be walking around a lot, the shoes are going to be really really important. So make sure they're comfortable. I know that for women it's an entire different problem, but for us men too. So don't leave the Gucci shoes at home. So.
You don't have to wear heels. I never did.
I mean,
Yeah.
like I did wear heels, but then I would bring like another pair to like
You have to
into.
stand for a while.
Yeah,
Yeah.
especially your footwear. Just be comfortable. But if you do want to wear heels, bring some backup.
For sure. I think in summary, you don't have to dress to the nines. Wear what's comfortable, but present yourself as if you're talking to a professional, which most of the time you are. Presentable, but be comfortable, be you. Don't let it distract from your presentation too much. On that note, what do you think maybe is an advantage to continuing a project a second year? Do you think that maybe helps or hurts your presentation in any way or your judging? And what are the benefits of starting a new project?
Well, I think there's definitely pros and cons to both. If you want to continue with an existing project, I think some of the advantages to this, it's definitely that you get to conduct a more in-depth analysis, and your findings, you can expand on those and fine-tune them. And the judges admire it when you show passion for a certain area, or that you've answered questions that you had in previous years. I think one of the drawbacks is it can get a bit repetitive, and your project does need to change from year to year. You can't just present basically the same thing you did before. So you need to maybe look into expanding it in a specific direction.
Yeah. In the previous in the French webinar, we spoke with Dominic, and he said that you'll be judged only on the new the new part of your project. So anything that was really only that was made the year before, a few years before, it can sort of be detrimental if you don't have anything new about the project. So that's why when I did my continuation projects, it was always I changed the engine, I changed pretty much everything about my programs, even the data, even the database. I just added the general concept was still there, right? So. But my project was done in an entirely different manner. So yeah.
Sure. So on that note, I'd just like to take a minute to just summarize sort of what we talked about today. The three main points are ways that you can step up your project are maybe more like your data interpretation is one that we talked about that's really, really big. Also, your presentation is important, and there's always room to get better at presenting. And lastly, just the scope and the importance, the impact of your idea and your project, what it means to you, what it means to others, how it impacts the scientific community, or maybe just your home life. I was wondering if any of you have any other sort of final points to add?
I think overall, also, it's just important to stay passionate and be proud of the work that you've done, and also just have fun. I mean, some of my fondest memories from high school do just come from science fair, and yes, the data, yes, everything is so important, but it's just the experience itself overall which really sticks with you.
Yeah, and I think on that note, like another great thing to remember is not only should you be proud in presenting and showing your work, but also make sure you take the time to look at what other students have done, not just because you might want to do similar ideas to them next year or see how they did their project, but because it's really cool to learn about science and a great way to connect with other students who like science like you. So definitely try and take some time, whether it's at your regional fair or at the Canada-wide Science Fair, to meet with the other students and see what they did as well.
Yeah, definitely make sure that your whole experience is centered about learning and having fun while learning, right? So not only learning more about your project, because that's really, that's one way to do it, but also learning more about, science in general. So, and keep interest in it. Yeah.
Definitely. Well, anyway, that's all the time we have today. But for anybody out there who would like to ask questions, the Twitter hashtag is hashtag CWSF, and you can feel free to fire any questions off or comment on the YouTube video. All of us will probably be around to ask questions or answer questions at times. Anyway, yeah, when you're working on your project, just good luck and have fun. And um, I wish you all the best.